Imagine gazing at Earth from space, not the vibrant blue and green sphere we know, but a giant, gleaming ball of glass. The familiar continents and oceans are now obscured by a smooth, reflective surface, casting dazzling reflections of the sun and stars. This transformation is not just a visual spectacle, but a profound alteration of our planet's very essence. It's a strange, almost eerie sight, isn't it? The Earth, once vibrant and full of life, now appears cold and uninviting. The glassy exterior creates an alien landscape devoid of the natural beauty we take for granted. The lush forests, sprawling deserts and vast oceans are hidden beneath this hard, translucent shell. What was once a world teeming with life is now encased in a hard, translucent shell. This glassy surface changes everything, from the way light interacts with the planet to the way heat is distributed. The atmosphere, once a dynamic and life-sustaining layer, is now trapped beneath this unyielding barrier. This is our thought experiment, to explore the dramatic and far-reaching consequences of an Earth transformed into a glass planet. How would this change affect the climate, the weather patterns, and the very possibility of life? Would the glass surface act as a magnifying lens, intensifying the sun's rays, or would it reflect them back into space, plunging the planet into a deep freeze? Such a scenario, while purely hypothetical, allows us to appreciate the delicate balance that makes our planet habitable. The thin layer of atmosphere, the presence of liquid water, and the right amount of sunlight are all critical factors that sustain life. Disrupting any one of these elements could have catastrophic consequences. It compels us to consider the complex interplay of sunlight, atmosphere, and water, and how these elements sustain life as we know it. The glass surface would alter this balance, potentially blocking essential sunlight or trapping too much heat. The water cycle, crucial for all living organisms, would be disrupted, leading to unknown and possibly devastating effects. Our journey starts by understanding how this glass Earth interacts with the most fundamental source of energy in our solar system, the sun. The sun's rays, which currently nourish our planet, would behave differently when striking a glass surface. Would the glass amplify the heat, creating scorching temperatures, or would it reflect the light, causing a chilling effect? Hold on to your hats, folks, because things are about to get interesting. As we delve deeper into this thought experiment, we'll uncover the surprising and intricate ways in which a glass Earth would differ from the vibrant, life-sustaining planet we call home. Prepare to be amazed by the unexpected vision of our world transformed. Sunlight, that life-giving energy, behaves differently when it encounters glass compared to our current Earth. When sunlight hits a glass surface, it doesn't just pass through or get absorbed like it does with soil, water, or vegetation. Instead, it interacts with the glass in unique ways that can significantly alter the environment. Instead of being partially absorbed by the ground and oceans, a significant portion of sunlight striking a glass Earth would be reflected back into space. This reflection is due to the smooth, shiny surface of the glass, which acts almost like a mirror. The more reflective the surface, the more sunlight is bounced back, reducing the amount of heat absorbed by the planet. This reflection would dramatically increase Earth's albedo, a measure of how much light a celestial body reflects. Albedo is a crucial factor in determining a planet's climate. A higher albedo means that more sunlight is reflected away, which can lead to cooler global temperatures. This is similar to how ice and snow reflect sunlight, helping to keep polar regions cold. A higher albedo means less solar energy absorbed, leading to a cooling effect. But that's not all. The cooling effect would be widespread, potentially altering weather patterns and climate zones. Regions that are currently warm might experience cooler temperatures, affecting ecosystems and human activities. Some sunlight would still penetrate the glass, but it wouldn't behave as usual. The glass would allow some light to pass through, but this light would be altered in its path and intensity. The transparency of the glass means that while some light gets through, it is not as direct or as strong as it would be without the glass barrier. The glass would refract or bend the light, scattering it in different directions than on our current Earth. This refraction can create a variety of visual effects, such as rainbows or halos, and can also affect how light is distributed across the surface. The bending of light can lead to areas of intense brightness and deep shadows, creating a more varied and dynamic lighting environment. This change in light distribution would impact everything from plant growth to weather patterns. Plants rely on consistent light for photosynthesis. and any changes in light intensity or direction can affect their growth cycles. Similarly, weather patterns are influenced by the distribution of solar energy, and changes in light distribution can lead to shifts in wind patterns, precipitation, and temperature. With less sunlight absorbed and more reflected away, Earth's temperature would plummet. The once temperate zones might experience winters far more severe, while the polar regions could become even more frigid and inhospitable. The exact extent of this cooling is difficult to predict, as it depends on factors like the thickness and composition of the glass, as well as cloud cover. However, one thing is certain: the climate as we know it would be a distant memory. This dramatic temperature shift wouldn't happen overnight. It would be a gradual process, but the consequences for life on Earth would be profound. Plants, the primary producers of energy in most ecosystems, rely on sunlight for photosynthesis. The altered light conditions on a glass Earth would pose a significant challenge. Some plants might adapt to the lower light levels and altered spectrum, but many would likely perish. The impact would ripple through the food chain, affecting herbivores that depend on plants, and the carnivores that prey on them. The once vibrant ecosystems we cherish, lush forests, vibrant coral reefs, and sprawling savannas, would struggle to survive in this dramatically altered environment. Section 5, A World Without Rain, the Hydrological Cycle in Chaos. The hydrological cycle, the continuous movement of water on, above, and below Earth's surface, would be thrown into disarray on a glass Earth. Evaporation, the process of water turning into vapor, would be significantly reduced. With less water vapor in the atmosphere, cloud formation would decrease, leading to less precipitation. The absence of rain would have devastating consequences. Deserts would expand, and regions once teeming with life would struggle to sustain themselves without this essential ingredient. Section 6, Sheltered Existence, Human Life in a Glass Sphere. For humans, life on a glass Earth would be a constant struggle for survival. The lack of food and water sources, combined with the harsh climatic conditions, would make it nearly impossible to maintain our current way of life. Imagine living in enclosed habitats, relying on advanced technology to filter air, regulate temperature, and produce food. We might even need to develop artificial sunlight sources to mimic the conditions necessary for plant growth. It's a bleak picture, but it underscores the importance of our current environment and the need to protect the delicate balance that makes life possible. Section 7, Technological Adaptation, Can We Survive? While the challenges are immense, humans are an innovative species. We might develop advanced technologies to adapt to the harsh conditions of a glass Earth. Perhaps we could create artificial ecosystems within our habitats, or develop genetically modified crops that thrive under the altered light conditions. We might even find ways to manipulate the glass surface itself, creating areas that allow for controlled sunlight penetration. Survival, however, would depend on our ability to adapt quickly and efficiently. Section 8, Seeking New Homes, Beyond the Glass Earth. Faced with such a dire situation, some might argue that the only viable option is to look beyond our glass-covered planet. Space exploration and the search for habitable exoplanets would take on a new urgency. This scenario highlights the importance of continued investment in space exploration, not just as a quest for knowledge, but as a potential safeguard for humanity's future. Section 9, A Universe of Possibilities, Reflections on Our Fragile Oasis. The hypothetical scenario of a glass Earth, while improbable, serves as a stark reminder of our planet's fragility and the interconnectedness of Earth's systems. Imagine a world where every action, every change is magnified and visible to all. This thought experiment forces us to confront the reality that our actions have far-reaching consequences, often beyond what we can immediately see or understand. The rivers that flow, the forests that breathe, and the ecosystems that thrive are all part of a delicate web of life that sustains us. It compels us to appreciate the delicate balance that makes life possible. The blooming of a single flower, the rise of the sun each morning, these are not just beautiful moments, but essential processes that maintain the equilibrium of our environment. Each element, no matter how small, plays a crucial role in the grand tapestry of life. The more we understand this balance, the more we can appreciate the intricate dance of nature that allows us to exist. While we may never face the challenges of a glass Earth, the lessons learned from this thought experiment are invaluable. Scientists and environmentalists work tirelessly to gather data and implement solutions that can help us mitigate the impact of our actions. Planting trees, conserving water, and reducing waste are just a few of the many ways we can contribute to the health of our planet. These efforts, though they may seem small, collectively make a significant difference. By understanding the potential consequences of such drastic environmental changes, we can better appreciate the need to protect our current home. The melting glaciers and the vibrant coral reefs are not just indicators of climate change, but also symbols of what we stand to lose. They remind us of the urgency with which we must act to preserve the natural wonders of our world. Every action we take today shapes the future of our planet. As we look out at the universe with its infinite possibilities, let us remember the preciousness of our own blue and green oasis. The vastness of space, with its countless stars and galaxies, offers a humbling perspective on our place in the cosmos. Yet, amidst this infinite expanse, Earth remains our only home, a unique sanctuary of life. It is a reminder that while we may dream of exploring other worlds, our immediate responsibility lies in caring for the one we have. Let's work together to ensure its preservation for generations to come. The joy of families exploring nature, the laughter of children playing in green spaces, these are the moments that define our connection to the Earth. By fostering a sense of stewardship and responsibility, we can create a legacy of sustainability and harmony with nature. Together, we can build a future where our fragile oasis continues to thrive, providing beauty and life for all who come after us.